Now we are going to derive the proof of the Gauss-Markov theorem. To do that, we need 5 assumptions that are strict exogeneity, so the residuals have to be equal 0. The expected value of the residuals must be equal to 0 given any regressor. The model we are considering must be linear. We need no collinearity, no perfect collinearity, so we need that the number of observation must be larger than the number of regressor, and then we also need that the rank of x is equal to k. Then we need the homoscedasticity assumption, that is the expected value of the residual squared given x is equal to sigma squared for each I. And then we need no serial correlation between the residuals, that is the expected value of the product given x, those residuals must be equal to 0 whenever I is different from j. So let me state what we are saying when we are talking about the Gauss-Markov theorem. So when we are respecting all of those assumptions, we say that the beta estimator OLS is the best linear unbiased estimator. That is, if exists another estimator, we call it beta tilde, that is linear and unbiased, then the variance of beta tilde is larger than the variance of beta OLS. So we have that the variance of beta tilde minus the variance of beta OLS is larger or equal than 0. Now, we shall prove this. So the first step is to define our estimators. So beta OLS, we must recall that we are estimating the model y that is equal to x beta plus e. The beta OLS, it is equal to x transpose x inverse times x transpose y, and beta tilde will be just equal to L, that represent a generic linear estimator, a generic linear estimator, so that L makes those beta tilde linear. Then we need that this beta tilde is unbiased. So we need to state some condition such that Ly will be an unbiased estimator of beta. So we take the expected value of beta tilde given x. That will be the expected value of L times y. L, it is a constant, so we take them out of the expectation operator. So it will be L times the expected value of y given x. So the expected value of y given x, we know that it is x beta. So we have that L multiplies x beta, and then we need that this estimator is unbiased. So we need that this is equal to beta. So our condition is that Lx is equal to the identity matrix. Now, to derive this result, that is the Gauss-Markov theorem, we need to state, to define another variable, that is z. Z will be the difference between L, that is the linear projection, and those the x transposed x inverse times x transposed. So we are taking the difference of what is multiplying y. Now we take the square of this, that will be zeta times zeta transposed, z, pardon. Then we multiply L minus x transposed x inverse x transposed times L minus x transposed x inverse x transposed, all this stuff transposed. So it will be equal to L minus x transposed x minus 1 x transposed times L transposed minus x transposed x inverse. Then we take the product, that will be L transposed minus L x transposed x inverse minus x transposed x inverse x transposed L transposed plus x transposed x inverse x transposed x transposed x inverse. Now this will be equal to I, this will be equal to I. So basically, and those simplifies. Then we are left with L transpose minus x transpose x inverse minus x transpose x inverse plus x transpose x inverse. And then this is equal to L times L transpose minus x transpose x inverse. Now, we proceed on computing. We take this and we'll z times z transpose, that is equal to L transpose minus x transpose x minus 1. We take this and then we will use it to later. Keep in mind this. So we take now we compute the variance of the beta tilde given x, that is equal to the variance of Ly given x, that will be equal to L variance y given x times L transpose. Since we are in the homoscedasticity case, this is equal to sigma square. Then this is equal to sigma square L times L transpose. What we notice here? We have this relationship that implies that L times L transpose is equal to Z times Z transpose plus X transpose X inverse. So we multiply sigma squared times Z transpose plus X transpose X inverse. And finally, we have that the variance of beta tilde is equal to sigma square times Z transpose Z plus sigma square times X transpose X inverse. And what is that? This is the variance of beta OLS given X. So the variance of beta tilde given X is equal to sigma square Z transpose Z times Z transpose plus the variance of beta OLS given X. So the variance of beta tilde given X minus the variance of beta OLS is equal to sigma square times Z times Z transpose that is larger or equal to 0. And then we have proven the Gauss-Markov theorem. So we need to state the case when this is equal to 0. This is equal to 0. To have this equal to 0, we need that Z transpose is equal to 0. And this implies that Z must be equal to 0. And to have zeta, Z, that we stated was to have this equal to 0, we need that L is equal to this. So we need that L is equal to X transpose X inverse times X transpose. And then we need that beta tilde must be equal to the OLS estimator in order to be the best linear unbiased estimator. And we have concluded.